Hi there, welcome back to this channel. In this video, I'm going to take you through how to find the inverse of a matrix using LU decomposition. So in our previous lessons, we have used LU decomposition to solve systems of equation using the Krauss method as well as the Doolittle method, and also how to use LU decomposition, how to find LU decomposition using the Gaussian elimination. So in this video, as I said, we're finding the inverse of a matrix using LU decomposition. And if this is the first time you're being on this channel, kindly subscribe so you get useful content like this. I have a problem here for me to use it to explain the concept to you. So it said find the inverse of this matrix, right? So what's the idea behind finding the inverse using LU decomposition? Now, generally, you know that any matrix times its inverse, right, gives the identity matrix. So let me say if a matrix A times its inverse A inverse, right, should give me what the identity matrix. For the identity matrix for 3 by 3, I'm going to have what 1 0 0 0 1 0, then I have 0 0 1, right? So this is the identity matrix for 3 by 3, right? So see something. If I have a matrix A, right, and I have the inverse, right? Then if I multiply this A by the inverse, I'm supposed to get what? The identity matrix. But what you're going to do is, we wouldn't carry the whole identity matrix together to find out our inverse. But what you're going to do is, we would take it section by section, okay? So our inverse matrix will have 3 columns. So let's say you have column 1, column 2, column 3. If I want to find the first column of my inverse matrix, then I'll multiply A as my what coefficient matrix. Let's say A, B, C, D, E, F, G, H, I, right? Multiply by an unknown x1, x2, x3, but will be equal to what? 1, 0, 0. And this equation here will give me what? The first what column of my inverse. Then I'll clean this 1, 0, 0. Then I'll also what substitute this 1, 0, 0 with my second column of the identity matrix, and that will be what 0 1 0. And this, after solving this same equation, I'll get the entries of my what second column of the inverse. Likewise, I'll do it for this. So the idea is you need to decompose your matrix A into what an LU form. So once you have an LU form, we use the principles for finding what systems of equation. That is, LZ is equal to B, then what UX is equal to what Z. So this X is what I'm representing it here. So you just assume some unknown Z which you don't know. So once you get a Z, you use your coefficient matrix, but the U here means that we need to express the matrix into an hypertriangular matrix. Then you multiply by X, then you equate it to the corresponding what columns to give us the corresponding entries of our inverse. So let's see how we're going to solve this problem. So now, in order to save time, and because we've done this in the previous video, I'll give you the decomposed form of this matrix straight away so that things will be faster. So if you want to really see the stepwise, please visit the videos as you subscribe to this channel. So I have 25, 5, 1, 64, 8, 1, then I have 1 4 4 12 1. So this is now my matrix, and the LU form I'm giving it to you as 1 2.56 5.76. Then I'm having 0 1. This is 3.5. Then this is 0 0 1. Then the U is simply giving us 25 5 1 0 0 negative 4.8, negative 1.56, then I'm having 0 0.7. So I have given you the LU form already. There is no need for us to go through the process once again. So at this point that you have the LU form, we simply go straight to finding our inverse of A. So how do you do that? You know the formula LZ is equal to B, right? So you simply take our what L. This is our L. So we take our L 1 0 0 2.56 1 0 5.76 0.5 then 1. you multiply by an unknown z, so z1, z2, z3, and this should be equal to what? The first column of our inverse. So take note, the first column of the identity matrix 3 by 3, and that is 1 0 0. Take note of this. That is 1 0 0. Because the idea, as I stated, is when you multiply a matrix by its inverse, the resulting matrix is what? An identity matrix, right? So our B part of the equation is going to be the respective columns of the identity matrix. So now here, as I have written this, we just have to solve for Z, then we find the corresponding X values. So finding the Z, this is forward substitution, right? So 1 times Z1 is what? 1. So Z1 is simply equal to what? 1. Then I come 2.56 by Z1, 2.56 by Z1, then plus what? Z2 is equal to 0. I know my Z1 to be 1, so my Z2 obviously is equal to negative 2.56. Then finally, my last 5.76 Z1. So I have 5.76 Z1 plus 3.5 Z2 plus Z3 is equal to 0. So I have 5.76. Z1 is given as 1. My Z2 is 3.5 multiplying negative 2.56 plus Z3 is equal to 0. So what is my Z3? So I have 5.76 plus 3.5 multiplying negative 2.56, right? And this is given as negative 0.2. So Z3 is simply equal to 0.2. So I simply have Z1, Z2, Z3 as 1. Then I have negative 2.56. Then I have 3.2. Okay. So once I get this, then I use Ux is equal to Z to find the X values. And the X value should be the first column of my of my inverse matrix. So I have the U. I'll have to carry the U. Yes. So I'll have to carry this U here to do that. So I'll simply have the U back again as 25, 5, 1, 0, negative 4.8, negative 1.56, and I'll have 0, 0, 0.7, right? This time the x1, x2, x3 is equal to the z1, which is 1, neg 2.56, then 3.2. So when I solve this equation, as I said, I'm getting the first entry. That's the first column of my inverse matrix. So here is backward substitution. So I have 0.7 by x3 is equal to 3.2. So my x3 is simply equal to 3.2 over 0.7. So 3.2 over 0.7. And that is giving us 4.57. 4.57, right? Then I come again, the second part, which is what? Negative 4.8x2 minus 1.56x3 is equal to negative 2.56, right? So I have negative 4.8. Then the x2 is what? I don't know, minus 1.56, but the x3 is what? 4.57, right? So if x is 4.57 equals negative 2.56, I simply find my x2. So when I find my s2, I'll simply have negative 1.56 times 4.57, right? And I'll simply add this. So let me do this. Negative 2.56, then I'll add this plus 7.1. Let me leave it to decimal places. All over negative 4.8. So I have negative 2.56 plus 7.13 over what? Negative 4.8, right? And this is negative 0.952. So this is negative 0.952. Then finally x3. What's x3? So the equation for x3 is 25x1. Let me clean it and write it well. So I'm having um, 25x1, right, plus 5x2 plus x3. I'm talking about this, and that should give me what, 1. So x1, I know it to be what, 4.57 plus 5 multiplying x2, which is negative 0.952 plus x3 is equal to 1. So I simply have 25 times 4.57, right, minus 5 open brackets 0.952. So I'm getting 109. So let me do it again. So I'm having 25 times. So okay, actually I'm looking out for x1. Okay, so I made some mistake with my substitution, right? So let me make the substitution once again. So I have 25x1 plus 5, and my x2 was what, negative 0.952. Then the x3 here is what, plus 4.57 is equal to 1. So actually I'll have x1 rather to be equal to, so if I have 5 times negative 0.952, I'm getting this plus 4.57 negative 0.19. So I'm having 1 here plus 0.19 over 25. What am I getting? I'm getting 1.19 over 25. 0.0476, right? 0.0476. So right now, my matrix, that is the inverse A, is now having the first entries to be what? X1, which is 0.0476. Then x2, which is negative 0.952. Then the x3, 4.57. Then the rest are left for us to find. So this process look quite tedious, but you need to use that to find. So we are not done. We go back again to find what's the second column entries. So to find the second column entries, we go by LZ again, right? So LZ is equal to, this time around, we will not make it 100 here as you see it here. So it will be what, 0 1 0 by the same equation. Okay, 0 1 0. So let me write my L back again. So LZ is equal to B. So what's the L? The L is 1, 2.56. Then I have 5.76, right? Then I have 0, 0, 1, 0. Then 3.5, 1, 1 like this. Then the Z is unknown. C1, C2, C3. Then the B now is the second column of our identity matrix. So 0, 1, 0. Right. So we go again. Yes. We find using forward substitution Z. So what is Z? Z1. So from here, I'll say that Z1 times 1 equals 0. So Z1 is 0. What is Z2? Z2 is what? 2.56 Z1 plus Z2 is equal to what? 1. We know that Z1 is 0, so here is 0. So Z2 is also equal to what? 1. Then finally, our Z3, we're going to have 5.76 multiplying Z1 plus 3.5 multiplying what? Z2 plus Z3 is also giving us 0. So with this, Z1 is 0, so it will go. So I'll have 3.5 multiplying 1 plus Z3 is equal to 0. So Z3 is simply equal to negative 3.5. And I'll write my Z's here. The Z1, C2, C3 is going to give me 0, 1, negative 3.5. Then I'll use what? My ux is equal to what? Z to find the second column of our inverse. So what's my u? I go back again. My u is simply 25, 25, 1. So 25, 25, sorry, 5, 1. Then I have 0, negative 4.8, 0, negative 4.8, then negative 1.56, right? Then I have 0, 0, 0.7. Multiplying the x, so x1, x2, x3 once again. Then our new z's, which is 0, 1, negative 0.5, right? So at this point, take note, we are still progressing with the inverse. The inverse is still here. So I can write my inverse, A inverse here is equal to the first column entry 0.0476, negative 0.952, 4.57. Then we come again. So here, we are going to use backward substitution. So 0.7 x3 is equal to negative 0.5. So x3 is simply equal to negative 0.5 over 0.7. So what are you getting? You're getting negative 2, right? So like 0.5 on 0.7. So 0.7. That is negative 5 instead, right? So x3 is equal to negative 5. We go again with this. So negative 4.8 x2 minus 1.56 x3 is equal to what? 1. So what is this? Negative 1 point x2, I don't know, minus 1.56 x3 is negative 5 equals 1. So I can find my x2 simply equal to what? What is this? Negative 1.56 times negative 5. That is 7.8. So 1 minus 7.8, right? So 1 minus 7.8, that is negative 6.8. So I'm going to get negative 6.8 over negative 4.8. So divided by negative 4.8, and I'm getting 1.417. 1.417. Okay. Then finally, what's the x3? I'm getting here 25x1 plus 5x2 plus x3 is equal to 0. What's x1? I don't know. So 25x1 plus 5, our x2 is 1.1417 plus our x3, which is negative 5, is equal to 0. So I simply do 5 times 1.417, right, minus 5. This is giving me 2.085. So my x1 is equal to negative 2.085 all over 25. So divided by 25, and I'm getting 0.083. So I'm getting negative 0.0834. So I add it up here. So here, negative 0.0834. This is the second column of the inverse. Then the x2 is 1.1417. That is for this one. Then the x3 is what we got first. That is negative 5. We are not done. Let me the last column. Then we are done with our simplification. Okay. So with the last column, we still go again. LZ is equal to B. So we write our L back again as usual. And our L is 1, 2.56, 5.76. Then this is all 0, 1, 3.5. This is 0, 0, 1. Multiplying Z1, C2, C3 is equal to the B. The B now is what? 0, 0, 1. This is the third column of the identity matrix. So we are just repeating methods by changing our B's. So from here, using forward substitution, Z1 is 0 because Z1 is 0. Then Z2, you are going to get 2.56 Z1 plus Z2 is equal to what? 0. Z1 is 0, so obviously Z2 is also 0. Then finally, 5.76 Z1 plus 3.5 Z2 plus what? Z3 is equal to 1. This is 0, this is 0, so Z3 is equal to what? 1. So I simply write Z1, Z2, Z3 to be equal to 0, 0, 1, right? So once I have this, you know what follows. US is equal to what? Z. So from here, my U is what? As usual, 25, 5, 1, 0, negative 4.8, then I have negative 1.56, and I have 0, 0, 0.7, like this. So this multiplying our x1, x2, x3 is equal to 0, 0, 1, 0, 0, 1. So what do we get? But before then, we have to reproduce this here so that we don't forget. We are still adding up. So this A inverse, right? A inverse is equal to, let me squeeze it somewhere here, 0.0476, negative 0.952, and I have 4.57. Here is negative 0.0834, and I have 1.417, then I have negative 5. So we add up as we proceed, okay? So that's the A inverse. So here I simply get 0.7x3 is equal to 1. Our x3 is equal to 1 over 0.7. So what is 1 over 0.7? So 1 over 0.7 is giving us 1.43. 1.4, let me make it 429. That is for x3. Then I come again, x2. So negative 4.8 x2 minus 1.56 x3 is equal to 0, right? So what is this? I don't know. Minus 1.56 multiplying 1.429 is equal to 0, right? So once you have this, you can solve this. So negative 1.56 times 1.429. Then after I'll multiply by negative 1. So I'm getting neg 4.8 x2 is equal to what? 2.229. Then I divide through by 4.8. So my x2 is equal to 2.229 over 4.8. So divided by 4.8, and I'm getting 0.4644. 0.4644, right? 0.4644. Then, so it will be negative because this is negative. So negative 0.464. Then let's find the x3. So finding the x3, I'll simply have this first equation. So 25x1. So let me clean here. I just want us to write the final answer somewhere here. So let me clean it bigger. So okay, so let's continue. So at this point, I'll have 25x1 plus 5x2 plus x3 is equal to 0. What is x1? I don't know. My x2 is what? I wrote it 0 point, so negative 0.464, right? Plus my x3, which is giving us 1.429, 1.429, right? Yeah. So I have to write the solution as well. So at this point, I'll have this to be equal to 0. So I need to find x1. So x1 is simply equal to 5 times negative 0.464, right, plus 1.429. So I'll send that. So I'm going to get 0.89 over 25. And what am I getting? So divided by 25. I'm getting 0.0357. 0.035. Okay, I'm having 64. So 6 is okay. So now let me circle my answers. This one I cleaned it here. So I'll have negative 0. So here is negative 0.0464. Then I have x3 to be. So circling my answers, I have 1 as my x1, as my x2, and as my x3. So let me write final my inverse. So the inverse is A inverse is now equal to the big bracket. So I have the first column 0.0476, negative 0.952, 4.57. And I have negative 0.0834, 1.417, negative 5. And I have negative 0.0, sorry, the next one here is 0.0356, not negative. So 0.0356. Then my x2 is 1, negative 0.0464. Then my x3 is 1.429. And this gives me the inverse of the matrix. Thank you for being with me in this video. It's been a long one. Please don't forget to subscribe and share for useful content like this.